This is Unit 3, Level 2, Multiplying Decimals. We're going to start out by multiplying decimals using this model. So let's talk for a moment, and let's go ahead and take an easy decimal that we can multiply. So we're going to take the whole number 4 times 1/10. Let's think about what multiplication means. Multiplication simply means repeated addition. So if I was going to take 4 times 1/10, really what I'm saying is I'm going to have 4 groups of 1/10. So it'd be 1/10 plus 1/10 plus 1/10 plus 1/10. Whenever I have a whole number times a decimal, I can model that by creating repeated groups of that decimal. In this case, I'm going to create 4 repeated groups. I'm going to go ahead and shade those in so I can show you what I'm talking about. So I'm going to pick a color and I'm going to shade in 1/10. 1/10 is simply 1 rod, or 10 of those hundredth blocks. If you saw me, I wrote 10. Wrote it as 10 hundredths at first. Same thing as 1/10. I'm going to shade that in. This is my first group. Okay. Now I'm going to pick another color and I'm going to shade this second group. This is my second 1/10. Now I'm going to shade that third group. And you can repeat, go back and forth between colors. I'm going to use 4 different colors just so you can see the 4 groups that I put out here, but you can go back and forth if you'd like. And now I'm going to do my fourth group. So whenever you have, and this works for a whole number, anytime you have a whole number times the decimal, you can model it by showing 4 repeated groups, because these are whole groups, because it's a whole number. Now, if I wanted to multiply this without a model, what I would do is I would take 4 times 1. 4 times 1 is 4. I'd forget the decimal. Then at the end, you count the number of decimal places that you have in the 2 factors. These are factors. And you have to have the same number of decimal places in your answer, which is called the product. Okay? So I know that if I take 1/10 plus 1/10 plus 1/10 plus 1/10, I know I'm going to get 4 tenths, and I show that model here. But here I would take 4 times 1, I'd forget the decimal, and then I'd notice that this factor has 1 decimal place. This factor, the top one, has no decimal places. So 0 plus 1 is 1. That means that my answer, the product, has to have 1 decimal place. So I start at the end and I move over 1 decimal place. There's my answer, 4 tenths. Now, we're going to erase all of this, and I'm going to show you what it looks like if you take a decimal times a decimal, because it's a little bit different how you would model it. Now, the algorithm, how you would multiply it without the model, is the exact same that I just showed you. So if you didn't get that the first time, that's okay. I'm going to show you several examples. So now let's go ahead and take that same 4, but in this time we're going to make it 4 tenths. And we're going to take those 4 tenths and we're going to multiply it by 3 tenths. Get my decimal to work. There we go. Okay. Now, this isn't a whole group of those 3 tenths. This is just a partial group, because we know decimals are just partial groups. They're not a whole group, they're partial groups. So what I'm going to do is I'm going to take a color and I'm going to shade 4/10. Going in one direction, because that's my first number that I'm multiplying. I'm multiplying that 4/10 by 3/10. So I'm going to go ahead and shade 3/10 going the other way. Now what you're going to notice is that this part down here that I'm shading right now doesn't overlap. But if I go up here to show those full 3/10, we're going to notice that they overlap. The overlapping part is really important because when you take 4/10 times 3/10, the answer is that part that overlaps. So let's go ahead and count if we can. It's a little easier when you shade on paper than when you shade on this on the tech here. But I believe we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 boxes shaded in both colors. Well, that's 12 boxes out of 100. So that would be 12 hundredths, which makes sense. 4/10 times 3/10 is 12 hundredths. Let's go back to that standard algorithm and let's prove it that way. So I'm going to take and write it. And I'm going to just forget about that decimal for a moment. And I'm going to take 4 times 3. 4 times 3 is 12. Now what I said before was that your product, which aka is your answer, needs to have the same number of decimal places as the total that are in your factors, aka the two numbers you multiply together. So when I look at these two numbers, I see that 4/10 has 1 decimal place, and 3/10 has 1 decimal place. 1 decimal place plus 1 decimal place is 2 decimal places. So my answer has to have 2 decimal places. So I start here at the end and I move it to the left. 1, 2 decimal places. 1, 2. Proved the same answer that I just got through my model. So when I multiply a whole number times a whole number, I have those consecutive groups. But when I multiply a decimal times a decimal, it's a partial group of that other partial group. So I have to do one going one way, and I have to shade the other going the other way and find my answer in that overlap part. Or I can use a standard algorithm. So let's go ahead and practice that standard algorithm with a couple more examples. What if we took 1 4/10 times 12 hundredths? Well, if I don't make a model, but instead choose to use my standard algorithm, I hope I practiced my standard algorithm for whole number multiplication. This is why we practice and start with that, because when you multiply by a decimal, it's really the same exact thing. You just worry about your decimal and where you're going to put it at the end. So now I'm going to go ahead and start multiplying. If these were whole numbers, because I'm going to forget my decimals for a moment, I would first start by taking 2 times 4. 2 times 4 is 8. I would then take 2 times 1. 2 times 1 is 2. Now if this was whole number multiplication, because I'm treating it just like that, when I went to go multiply my second number, I'm now multiplying by a 10, so I would add a placeholder, 0. And then I would continue to multiply. 1 times 4, which is 4, and 1 times 1, which is 1. I would then add. Guess what? It's all the same. We're still going to do the exact same thing. The difference comes in is that now I have to put in a decimal. So again, I have to look at the decimal places in my products. So my decimal places that are in my in my factors. Excuse me, because it's going to have the same number in my product, which is my answer. So now when I come up here and I count, I see 1 4/10 has 1 decimal place. 12/10 has 2 decimal places. 1 plus 2 is 3. So my answer has to have 3 decimal places. I start at the end and I move it over 1, 2, 3. So my answer is 168 thousandths. So again, I could just multiply like normal and then worry about my decimal in the end. Again, my product, aka my answer, has to have the same number of decimal places as my 2 factors when I total my 2 factors. So let's go ahead and try another example. What if I did 42 hundredths times 17? Let's go ahead and multiply like normal and forget that decimal. I would first start out by 7 times 2, which is 14, carry my 1. Then 7 times 4, which is 28, plus 1, which is 29. I'm no longer multiplying by that 7. I'm now multiplying by a 10, so I'm going to go ahead and add a 0. Then I'll take 1 times 2 and 1 times 4. I'm going to then add. Now that I have finished multiplying, that's when I go back up to my factors and I count the decimal places. In 42 hundredths, there's 2 decimal places. In 17, there's 0 decimal places. So my answer, the product, has to have 2 decimal places because 2 plus 0 is 2. I start at the end and I count over 2 places to the left. 1, 2. So 42 hundredths times 17 is 7 and 14 hundredths. It's the same thing because 17 is a whole number as taking 42 plus 42 plus 42 hundredths, or we look at decimals as money often, so 42 cents, and keep doing that 17 times. I could make a model for this, but it becomes a little bit faster and a little bit more efficient to do our standard algorithm. This is Unit 3, Level 2, Multiplying Decimals mini lesson.